Right now, sitting in an archive in Chile, there's a photograph of an object that should not have been photographed at all, taken by a telescope that was not even looking for it, 10 full days before the rest of humanity even knew it existed. And when scientists finally lined that image up against what the James Webb Space Telescope had independently been measuring millions of miles away, the two data sets matched so precisely that researchers described the moment not as a confirmation, but as a collision of evidence. Two of the most advanced observatories ever built, working completely independently of each other on completely different continents of the sky, had somehow locked onto the exact same target. And what they found, once you strip away the headlines and actually look at what was published, is stranger than almost anything either instrument has confirmed before. This is the story of what the James Webb Space Telescope and the Vera C. Rubin Observatory actually saw, why the timeline behind it is stranger than most people realize, and why an object that formed before our sun even existed is still, right now, being tracked by two of the most powerful eyes humanity has ever built. Stay with me, because this is not a story that needs any exaggeration to be genuinely unsettling. The real version is already strange enough on its own. Before we get into what these two telescopes actually found, you need to understand just how different they are from each other, because that difference is exactly what makes their agreement so significant. The James Webb Space Telescope sits nearly 1 million miles from Earth, parked at a gravitationally stable point in space called the second Lagrange point, reading the chemical fingerprint of distant objects by breaking their light apart into its individual wavelengths. It does not take pictures the way you'd normally think of a photograph. It reads the composition of things, atom by atom, molecule by molecule, from unimaginable distances. The Vera C. Rubin Observatory is something else entirely. It sits on a mountaintop in Chile, at an elevation of nearly 9,000 feet, and instead of staring intently at one single target the way Webb does, it does the opposite. It sweeps. Attached to an 8.4-meter telescope is the largest digital camera ever constructed, a 3,200 megapixel instrument roughly the size of a small car, designed specifically to photograph enormous swaths of the night sky, over and over every few nights, for 10 straight years, as part of a survey called the Legacy Survey of Space and Time. One instrument reads chemistry with surgical precision. The other watches almost the entire visible sky, repeatedly waiting for something to move. And in the middle of 2025, both of them, using completely different methods for completely different reasons, ended up staring at the exact same object. That object is called 3I/Atlas, and the story of how it was found begins not with a discovery, but with something astronomers only figured out afterward. On July 1st, 2025, a modest telescope system called ATLAS, short for the Asteroid Terrestrial Impact Last Alert System, operating out of a facility in Rio Hurtado, Chile, caught a faint point of light moving in a way that immediately looked wrong. It wasn't looping around the sun the way every comet and asteroid native to our solar system does. It was moving on what astronomers call a hyperbolic trajectory, a wide open arc that only makes physical sense if the object came from somewhere outside the sun's gravity entirely, and is simply passing through on its way to somewhere else, never to return. Within days, the object was confirmed and formally named. The letter I in its designation stands for Interstellar. The number 3 means it is only the third such object humanity has ever confirmed, after a strange cigar-shaped visitor called Oumuamua in 2017 and a more ordinary-looking comet named Borisov in 2019. Here's where the story takes its first genuinely strange turn, and it has nothing to do with the object itself. It has to do with the fact that astronomers went digging back through older data, hunting for any earlier sighting that might have been captured by accident before anyone knew what they were looking at. And what they found reframed the entire discovery. Buried inside the commissioning data of the Vera C. Rubin Observatory, an observatory that was still in its testing and calibration phase and was not even close to beginning its official 10-year survey yet, sat a clear, high-resolution image of 3I/Atlas captured on June 21st, 2025. That is 10 full days before the object was officially discovered by anyone. Rubin's enormous camera had been pointed at that patch of sky for entirely unrelated testing purposes, fine-tuning its instruments, checking its data pipelines, working through the mountain of calibration required before a telescope. This sensitive can be trusted with real science. Nobody on the Rubin team was looking for an interstellar visitor. They found one anyway, sitting quietly inside their test data, because the camera was simply that good at capturing anything that happened to be in frame. Researchers led by C. O. Chandler at the University of Washington eventually pulled together a full paper on the observation, and when they widened their search even further back through the archive, they found fainter traces of the object stretching back even earlier, all the way to May 7th, 2025, 55 days before its official discovery date. An interstellar object had been sitting in humanity's data, completely unnoticed, for nearly 2 months before anyone realized what they were looking at. If a detail like that, a multi-billion-dollar telescope accidentally photographing an interstellar visitor before anyone even knew to look for it, is the kind of thing that genuinely fascinates you, this is exactly the kind of story worth sticking around for. So go ahead and subscribe right now, because the deeper this goes, the stranger the actual confirmed science gets, and you do not want to miss where this leads next. Once astronomers understood what they were tracking, the numbers alone were enough to raise eyebrows. At the moment of its official discovery, 3I/Atlas was already moving at roughly 137,000 miles per hour, and it was still well outside the orbit of Jupiter, meaning something else, some other star system entirely, had accelerated this object to that speed long before it ever encountered our sun's gravity. By October of 2025, astronomers had calculated its orbital eccentricity, a number describing how extreme and how open its trajectory actually is, and it came out to roughly 6.1, making 3I/Atlas more extreme in its path through the solar system than either of the two interstellar visitors that came before it. Of the 3 confirmed objects humanity has ever tracked from outside our own solar system, this one is moving on the least bound, most aggressive trajectory of the group. And it is the one that Vera Rubin's camera happened to catch by pure accident before Atlas itself ever raised the alarm. It helps to actually understand how different this object behaved compared to the 2 interstellar visitors that came before it, because the contrast is part of what made scientists take it so seriously so quickly. Oumuamua, spotted back in 2017, tumbled through its brightness cycle in a way that suggested an elongated, almost cigar-like shape, showed no visible coma or tail at all, and displayed a faint but measurable acceleration that could not be fully explained by gravity alone, a genuine mystery that generated its own share of headlines at the time and has never been fully resolved. Borisov, found 2 years later in 2019, behaved much more like an ordinary solar system comet, with a conventional dusty tail and a chemical makeup that mostly matched what astronomers already expected to find. 3I/Atlas does not fit neatly into either template. It has an obvious active coma, much like Borisov did, but its chemical fingerprint and its staggering age place it in an entirely different category from anything either of its 2 predecessors ever showed. Some researchers reviewing older archival data have also pointed out faint hints of activity in pre-discovery images captured by NASA's TESS spacecraft, taken before the object was officially found, suggesting it may already have been venting gas at a distance from the sun where that kind of activity would be considered highly unusual for an ordinary solar system comet. 7 weeks after that first confirmed detection, NASA turned the Hubble Space Telescope toward the incoming object on August 20th, 2025. Hubble could not see the object's solid core directly because a fuzzy cloud of gas and dust called a coma had already formed around it, the same way it does around most active comets as they warm on approach to the sun. But by carefully modeling the glow of that coma, astronomers were able to put rough boundaries on the size of the icy body hidden underneath, somewhere between roughly 1,400 feet and 3.5 miles across. That is an enormous range of uncertainty, and it exists specifically because there was no prior data on this object anywhere in human history to compare it against. Every single measurement had to be built from scratch, in real time, on an object that would only be visible for a limited window before it disappeared again forever. This is where James Webb enters the story directly, and where the findings genuinely start to earn the word terrifying, not because anything about them is dangerous, but because of how thoroughly they broke the expectations scientists walked in with. As 3I/Atlas moved closer to the sun and began warming up, both James Webb and NASA's newer SPHERIX mission got a detailed look at exactly what gases were pouring off its surface. In a normal solar system comet, you would expect water vapor to dominate that outgassing, since water ice is the most common frozen material comets in our own neighborhood tend to carry. That is not even close to what these instruments found. The coma surrounding 3I/Atlas was overwhelmingly carbon dioxide, making up roughly 95% of the detected gas, with water accounting for only a small fraction of the total. Webb also picked up tiny particles of water ice and carbon monoxide gas mixed into the coma, painting a picture of a genuinely layered, complicated mixture of frozen materials, all warming up together as the object approached the sun for the first time in what may be billions of years. A comet built almost entirely around carbon dioxide at this particular distance from a star is deeply unusual, and it strongly suggests this object formed somewhere extremely cold, far colder than the region where our own solar system's comets originally condensed, in a part of some ancient stellar disk where carbon dioxide ice could form and survive far more easily than ordinary water ice ever could. The age of this object is where the story stops sounding like ordinary astronomy and starts sounding almost impossible. Early estimates, based purely on the object's orbit and the general population of stars in the part of the galaxy it appeared to be arriving from, suggested an age of roughly 7 billion years, older than our entire solar system. But the real confirmation took nearly a year of patient follow-up work to fully nail down. Webb's near-infrared spectrograph observed the object on August 6, 2025, and its mid-infrared instrument revisited it 3 more times in December of that year, after the object had swung past the sun and was heating up under fresh solar exposure. Researchers led by Martin Cordner at NASA's Goddard Space Flight Center used that data to measure the ratio between 2 forms of carbon in the escaping gas, ordinary carbon-12 and a heavier isotope called carbon-13. Almost all the carbon anywhere in our galaxy is originally forged inside stars considerably more massive than our own sun, and the balance between these 2 isotopes shifts slowly and measurably over cosmic time, as generation after generation of stars are born, live, die, and enrich the surrounding galaxy with new material. What Cordner's team found was a carbon isotope ratio containing far less carbon-13 than anything ever measured in our own solar system, and less than anything measured even in the young, actively forming planetary disks around other, much closer stars. Working backward through models describing how the galaxy's chemistry has changed over billions of years, they concluded that this object most likely accreted its ice somewhere between 10 and 12 billion years ago, during an early, intensely active period of galactic star formation that astronomers sometimes call cosmic noon. Our own solar system, for comparison, is about 4.6 billion years old. The universe itself is roughly 13.8 billion years old. This means 3I/Atlas may have already been drifting silently through interstellar space for longer than our sun has even existed, a fact so large it is genuinely difficult to hold in your head for more than a few seconds at a time. The team published these results in the journal Nature in June of 2026, and Cordner told reporters at the time that it might be, in his own words, the oldest object ever observed passing through our solar system. Alongside that carbon measurement, Webb's instruments picked up something else hidden inside the water the object was releasing. The ratio of deuterium, heavier form of hydrogen, to ordinary hydrogen came back significantly higher than anything typically found in solar system comets, with some analyses placing the enrichment at roughly 10 times higher, and other estimates going even further than that. That kind of deuterium enrichment tends to form specifically in extremely cold environments, colder than negative 243 degrees Celsius. Combined with the carbon isotope data, it painted an unusually consistent picture from 2 completely independent chemical measurements. This object formed somewhere unusually frigid, and unusually long ago, in a part of the galaxy current models associate with what astronomers call the galactic thick disk, an older, more scattered population of stars sitting apart from the flatter, younger disk our own sun calls home. An astronomer named Darrell Seligman at Michigan State University, who was not directly involved in the nature study but has studied the object extensively, told reporters that before these measurements, getting this level of detailed chemical information from an interstellar object was something scientists could previously only dream about. That would already be more than enough to justify a headline. But the detail that actually pulled this story out of specialist journals and into mainstream attention involves a discovery that still has not been fully explained down to the exact mechanism responsible for it. In October of 2025, a research team using the UVES spectrograph on the European Very Large Telescope in Chile detected something inside the object's coma that nobody was expecting to find there, a plume of nickel gas, later independently corroborated by additional data gathered at the Keck 2 telescope in Hawaii. On its own, detecting nickel vapor coming off a comet is not shocking. It has been seen before in a small handful of solar system comets, including Borisov, the interstellar visitor discovered back in 2019. What made this specific detection different was what was conspicuously missing. Every previous time nickel vapor has ever been detected venting from a comet, it has come paired with iron vapor, because the two metals are forged together inside dying stars and supernovae, and travel through space chemically bound to each other, sometimes described by researchers as cosmic twins. In 3I/Atlas, the nickel signal came through strong and clear, while the iron signal was almost completely absent. Astronomers scrambled to figure out how that was even physically possible. Comets are generally far too cold at these distances from any star for solid metal grains to sublimate directly into gas form at all, which meant something else had to be releasing that nickel through an entirely different chemical pathway, most likely a nickel-bearing molecule that breaks apart under sunlight far more easily than whatever compound is holding the iron in place. There's a known, if unusual, natural process involving compounds called nickel carbonyls that could, in principle, explain this kind of low-temperature nickel release without any accompanying iron, and most astronomers currently studying 3I/Atlas consider that the most likely explanation, alongside the possibility of other refractory nickel-bearing minerals behaving differently than iron-bearing ones when gently heated at extreme distance from a star. But it is worth being completely honest about where the science actually stands. At the time these observations were published, researchers had not fully confirmed which specific compound was actually responsible, and several published papers described the detection using words like extremely puzzling, because nothing in the entire solar system come to record looks quite like this pattern. Researchers have also pointed out that faint traces of this same nickel dominant signature, though far less pronounced, were spotted years earlier in Borisov as well, which suggests this unusual chemistry might be a broader feature of comets that formed outside our solar system altogether, rather than something unique to this single object. It was that specific anomaly, nickel with essentially no iron, that pulled the conversation toward its most sensational edge. Harvard theoretical physicist Avi Loeb, who has spent much of his career actively searching for possible signs of extraterrestrial technology, publicly pointed out that nickel without iron is otherwise mainly associated here on Earth with a specific industrial refining process. And he raised the possibility, repeatedly and publicly, that this pattern could indicate something artificial rather than natural. He also pointed to the object's trajectory, which happens to pass unusually close to the plane in which the planets orbit, as another data point he considered worth flagging for further scrutiny. It is important to say clearly and directly that this remains very much a minority position within the broader scientific community. The overwhelming majority of astronomers actually working on 3I/Atlas, including the very teams responsible for these detections, favor natural chemical explanations rooted in the object's unusual, ancient, and extremely cold formation environment, not a manufactured origin. Several researchers have also noted that survey systems like ATLAS are simply more likely to catch objects whose paths happen to cross close to the ecliptic plane, purely because that region of sky gets searched far more intensely and frequently than other areas, which weakens the case for reading anything deliberate into the trajectory itself. The seriousness with which mainstream scientists treated the unknown here is itself worth pausing on, because it shows exactly how real science actually handles a genuinely open question, rather than how the internet tends to handle one. A team of researchers pointed the Allen Telescope Array, a radio observatory built specifically to search for potential signals from extraterrestrial technology, directly at 3I/Atlas during its passage through the solar system, systematically scanning across a wide range of radio frequencies for anything resembling an artificial transmitter. This was not a fringe stunt or publicity exercise. It was a peer-reviewed techno-signature search, conducted using the exact same rigorous methodology applied to any other legitimate candidate target anywhere in the sky. The result came back clean. No artificial radio signal was found coming from the object. At any frequency the array was capable of monitoring. That negative result rarely makes it into dramatic headlines, but it matters enormously because it demonstrates that when a legitimate scientific question got raised, however unlikely the eventual answer, the actual response from the scientific community was not idle speculation from a comfortable distance. It was to point a real instrument at a real target and report exactly what was and was not found. The object's physical size and mass came into sharper focus only after it had already passed its closest approach to the Sun. Early observations noted that 3I/Atlas was not developing the kind of long, dramatic tail that sunlight pressure typically pushes off an actively venting comet, which led to speculation about whether its core might be unusually massive or its surface unusually resistant to that pressure. Some early rough estimates based on that missing tail put the object at somewhere north of 33 billion tons, dramatically heavier than Borisov before it. Once the object moved past its closest point to the Sun, and astronomers were finally able to separate the glow of the solid core from the surrounding coma using multiple Hubble observations, taken across late 2025 and early 2026, they arrived at a far more refined figure, an effective diameter of approximately 2.6 kilometers, with an uncertainty of around 0.4 kilometers, considerably narrower than the earlier estimate and confirming this was a genuinely large object by interstellar standards, notably bigger than Borisov, even if the more extreme early mass estimates were not ultimately what the refined measurements supported. This particular interstellar visitor also received a level of direct, close-range scrutiny that neither of the two objects before it ever came close to receiving. On October 3rd, 2025, during its closest approach to Mars, 3I/Atlas passed within about 29 million kilometers of the planet, close enough that NASA's Perseverance rover, multiple Mars orbiters, and the European Space Agency's own orbiters all managed to capture images of it, marking the closest any spacecraft in history had ever gotten to an interstellar object. The European Space Agency's JUICE spacecraft, already en route toward Jupiter's icy moons, attempted its own observations as the comet passed nearby, using its cameras, spectrometers, and particle sensors to add yet another independent vantage point to the growing data set. Ground-based observatories joined the effort as well. The Gemini North Telescope in Hawaii captured a detailed image on November 26, 2025, carefully processed to correct for the streaking star trails caused by tracking such a fast-moving target, giving the public one of the clearest visual looks yet at what this ancient traveler actually looked like, set against the background stars. Here is why any of this should genuinely matter to you, beyond simply being a compelling story. Every comet native to our own solar system formed from the same disk of material that eventually built the planets, which means studying them mostly tells us about our own local chemistry, our own local history. 3I/Atlas is fundamentally different. It is a physical sample of material that condensed around a completely different star, under different temperatures, at a different point in the galaxy's own history. And it has been drifting silently across the void for billions of years, never disturbed by any star's heat until it happened to pass through ours. That gives researchers something they have genuinely never had before, a direct chemical comparison point capable of testing whether the process of building icy bodies works the same way everywhere in the galaxy, or whether it actually varies significantly depending on exactly where and when a given star system happened to form. The nickel and iron anomaly specifically is now forcing cometary scientists to reconsider long-standing assumptions about how metals become locked into, or eventually released from, ice at extreme distances from any star, assumptions that were, until now, built almost entirely on a sample size limited to solar system comets alone. If you have made it this far, it is worth taking a second to like this video, because it genuinely helps stories like this one, built on real published research rather than manufactured hysteria, actually reach the people who would appreciate hearing the accurate version instead of the exaggerated one circulating everywhere else online. As for where things actually stand right now, the timeline since discovery has moved quickly, and it is worth laying it out with precision. The object reached perihelion, its closest approach to the Sun, on October 29, 2025, passing at a distance of about 203 million kilometers, just inside the orbit of Mars, with its speed peaking at roughly 246,000 kilometers per hour at that exact moment. After that, it passed near Venus on November 3, 2025, at about 97 million kilometers, and its closest approach to Earth came on December 19, 2025. At a distance of about 270 million kilometers, roughly 1.8 times the distance between Earth and the Sun, or more than 700 times the distance between Earth and our own moon. NASA and the European Space Agency have both been explicit and entirely consistent on one specific point throughout this entire story. 3I/Atlas posed no threat of impact at any stage of its journey through our solar system, and it never came remotely close enough for that to be a realistic concern for anyone. After swinging past Earth's distance, the object continued outward, passing near Jupiter on March 16, 2026, at roughly 54 million kilometers. As of the middle of 2026, Webb has continued to revisit the object as it recedes, and in a study released around June of that year, researchers reported the telescope's first mid-infrared chemical fingerprint of methane on the object, adding yet another data point to the growing picture of its unusual ancient composition, gathered while there was still a narrow window of time before the object grew too faint and too distant to study in any further detail. For a stretch of that timeline, the object actually vanished from view entirely. Around late October of 2025, its position lined it up directly behind the Sun as seen from Earth, a configuration astronomers call solar conjunction, which made it impossible for any ground-based telescope to observe it safely. It re-emerged on the other side of the Sun in early December of 2025, giving observatories around the world a fresh window to catch it again before it continued its long retreat outward. The naming convention behind all of this is not just bureaucratic trivia either. Under the system the International Astronomical Union uses, the leading letter tells you exactly what kind of object you are looking at, and the number tells you how many of that kind humanity has confirmed so far. The I in 3I/Atlas marks it permanently as interstellar, distinguishing it forever from every comet that was actually born inside our own solar system. And the number 3 tells you, at a glance, that our entire species is still only 3 confirmed sightings deep into what is almost certainly an enormous, largely invisible population of these objects drifting silently through the galaxy around us. What we do know with real confidence now is that this will not be the last one to visit. The Vera C. Rubin Observatory, having already stumbled onto this exact object purely by accident during its own testing phase, is now expected to find many more of these visitors deliberately, and far sooner after their arrival, once its full 10-year legacy survey of space and time officially gets underway. Unlike Atlas, which was built primarily to hunt for asteroids that might threaten Earth and only found this particular comet as a fortunate byproduct of that broader search, Rubin's entire survey strategy is specifically designed to repeatedly scan enormous swaths of the sky, night after night, dramatically increasing the odds of catching the next fast-moving interstellar object early in its approach, while there is still enough time to redirect other telescopes, and potentially even spacecraft, toward it before it passes through and disappears for good. Some researchers are already unofficially referring to whichever object turns up next simply as 4I, whenever and wherever it eventually gets found. The 3 interstellar visitors confirmed so far, Oumuamua, Borisov, and now 3I/Atlas, are almost certainly not rare at all. Researchers increasingly believe objects like these have been silently drifting past our sun since the solar system's earliest days, and that we simply lacked the technology to notice them until roughly the last decade. Now that we finally have that technology, spread across 2 of the most capable observatories ever constructed, one reading chemistry with surgical precision nearly 1 million miles from Earth, the other sweeping the entire visible sky from a mountaintop in Chile, the pace of discovery is genuinely expected to accelerate substantially in the years immediately ahead. And that is really the story underneath the story here. Not a manufactured mystery, not a hidden signal, not a countdown to anything. Just 2 of the most sophisticated instruments humanity has ever built, working completely independently of each other for entirely different reasons, that happen to lock on to the exact same ancient traveler passing silently through our neighborhood, and confirmed piece by piece, chemical signature by chemical signature, that it is stranger, older, and more genuinely important than almost anyone expected when a faint point of light first blinked into view over a modest telescope in Chile back on July 1st, 2025. Right now, 3I/Atlas is somewhere out past Jupiter's orbit, moving away from us at more than 60 kilometers a second, carrying chemistry that was locked into ice before our own sun had even finished forming. It will never slow down, never turn around, and never pass this way again. Every instrument that was ever going to study it up close has already had its turn. What remains behind is not a mystery solved, and it is not a threat avoided, because there was never a genuine threat to begin with. What remains is a complete data set, sitting carefully archived across Hubble, Webb, Rubin, and a dozen ground-based observatories around the world. The recorded fingerprint of a piece of another part of the galaxy entirely, one that happened to drift close enough for us to actually measure it once, before it disappeared for good. And somewhere out there right now, quietly inbound, completely unnoticed, a 4th interstellar object is almost certainly already on its way. And tonight, nobody on Earth knows it yet, when it finally does arrive, there's a very real chance that the Vera Rubin Observatory, the same instrument that accidentally photographed this one 10 days before anybody was even looking, will be the first to catch it too. If this kind of deep, sourced, genuinely researched space story is what you come here for, subscribing helps enormously. Dropping your thoughts on the nickel anomaly in the comments genuinely shapes what gets covered next. And sharing this with someone who would get a real kick out of it is one of the easiest ways to keep stories like this one, built on real data instead of manufactured panic, reaching the people who actually want to hear them.